Here we go with a video on solving radical equations. So when you solve for x, you have to make sure you check your answer because it doesn't always work mathematically when you substitute it back into the original problem. So always make sure you check your answer when you're done. So what we need to do here is we have to get x by itself. So when you're working with radicals and exponents, what you want to do is you want to get just the most basic part of that radical or exponent by itself. So you need to get the cube root of x by itself before you do anything else. So in this case, you're going to add 4 to both sides, and you're going to end up with the cube root of x is equal to 4. So now you've got the radical by itself. It's ready to go. What you need to do is you need to cube both sides. And that will make the cube root and the cube cancel each other out, and that's going to give you x equals whatever 4 cubed is. So all you need is your calculator if you can't do it in your head, and you're going to end up with 64. So like I mentioned, you want to make sure you check. So you plug it back into the original equation. So you're going to get the cube root of 64 minus 4 is equal to 0. The cube root of 64 is 4 minus 4 is equal to 0, and it works. So you're good to go. X equals 64. Next one. What you want to do is you want to get just the exponent by itself. So in this case, the first thing you need to do is divide both sides by 2. And you get x to the 3/2 power is equal to 125. So to get rid of a 3/2 power, what you need to do is you need to raise both sides to the reciprocal exponent power. So you need to raise both sides to the 2/3 power. That will cancel out your 3/2, so you're just going to be left with x again. And that's going to be equal to 125 to the 2/3 power. Now you can try to do that by hand, or you can actually just take your calculator and raise 125 to the 2/3 power, and it's just going to tell you what the answer is going to be. So use your calculator, and you should end up with 25. Okay, that's it. That's all you have to do is use your calculator. But then, of course, you've got to check it. So we're going to have 2 times 25 to the 3/2 power is equal to 250. That you can actually just use your calculator. So 2 times, and then you can type 25 raised to the 3/2 power. And it's going to tell you 250, and you're good to go. So it is a solution. Next example. You must get this radical by itself. So the first thing you do is subtract 2 from both sides. And you're going to end up with the square root of 4x minus 7 is equal to 3. Now that you're here, square both sides to get rid of a square root. That's going to give you 4x minus 7 is equal to 9. Add 7 to both sides, so 4x is equal to 16. And x is equal to 4 after you divide by 4. And then, of course, make sure you go back and check. So the square root of 4 times 4 minus 7 plus 2 is equal to 5. 16 minus 7 is 9. The square root of 9 is 3. And 3 plus 2 is definitely equal to 5. So yes, 4 is a solution. All right, so that's how you solve these radical equations. Just make sure you get the exponent or the radical by itself. So here's 2 more examples. For the first one, it's a little bit different. Now you've got 2 radicals, but you've got a 0 on this side. So to make this problem much easier, the first thing you want to do is you want to make sure you add that 2 root x to the other side. So now what you can do is you can just square both sides. Be careful on the right though. When you square this, you're just going to be left with 3x plus 2. But this is going to be equal to 4x, and because this 2 is not inside the root, when you square it, it still becomes a 4. And now you just solve. So 2 is equal to x after you subtract the 3x from both sides. And of course, make sure you plug it back in. You're going to get the square root of 8 minus the square root 2 root 2, which is 0. So it's going to work out, so you are good to go. Next example. This is when something fun's going to happen. So you've got to subtract your 10 from both sides, and you're going to have 6x minus 5, and the square root is equal to a negative 7. So you're going to square both sides, and you're going to end up with 6x minus 5 is equal to 49. and then take it from there. So 6x is equal to, add 5 to both sides, and you get your 54. So x is equal to 9. So, like I said, this is where an example of something fun is going to happen. When you plug it back in, you're going to have the square root of 6 times 9 minus 5 plus 10 is equal to 3. So, this is going to give you the square root of 49, which is 7 plus 10 is equal to 3. Does 17 equal 3? No, it doesn't. So, you actually have no solution with an extraneous solution of 9. That's the proper way to write it in set notation. But, like we've talked about in the past, an extraneous solution is a solution that you get when solving, but it really doesn't work mathematically when you plug it back in. And that's because we squared a negative 7 and it became a 49. But in the first place, you would never be able to get that to happen. You would never be able to take the square root and get a negative. Okay? So, that's that. So make sure you always go back and check. So here are 3 more examples. And these are a little bit trickier than what you first originally thought they were going to be. So let's take it from the top. First one. This one, it just looks like we got to square both sides to get rid of the radical, which is true. However, look what you're squaring. On the left side, you're squaring a quantity, and you have to FOIL. So that's going to be x minus 4 times x minus 4 is equal to 2x. So then you FOIL that, you get your x squared minus 8x plus 16 is equal to 2x. X squared minus 10x plus 16 equals 0. So x minus 8 and x minus 2 equals 0. So x is equal to an 8 and a 2. So you want to make sure you check both, because there's a good chance one of them isn't going to work. So let's see. Let's do 8 minus 4 is equal to the square root of 2 times 8. Is 4 equal to the square root of 16? Yes, it is. So your 8 works. Now let's check the 2. 2 minus 4 is equal to the square root of 2 times 2. Does negative 2 equal the square root of 4? No, it doesn't. The square root of 4 is 2. This is not a solving where we're doing a plus or minus. So the square root of 4 is 2, and a negative 2 does not equal 2. So, again, if you'd like to see how you write this answer properly, you would call your solution 8 in a set with your extraneous solution of 2. Now, again, for the purpose of this class, I would be happy enough if you told me that x equaled 8 and you have an extraneous solution of 2. You just have to show me, prove to me that you know that you cannot just write 8 and 2, because the 2 really doesn't work. All right? Next example, add 2/5 to both sides. So you get x to the 1/3 power is equal to 2/5. To get rid of a 1/3 power, what you need to do is cube both sides. So x is equal to, and then of course you're just going to use your calculator, and if you type 2/5 in parentheses and raise that to the 3rd power, math bracket, it's going to give you 8 over 125. All right, and that's it. Of course you would check it, but that one's going to work without any problems whatsoever. And the last one, last tricky one of the day. So what we're going to do here is we're going to have to raise both sides to the 2/3 power. So raise both sides to the 2/3 power. And then you need to think about what is -6 to the 2/3 power. If you type -6 to the 2/3 power in your calculator, it is going to give you a decimal. And that's because it doesn't have an even cubed root for 36. It's going to give you 3.3019 yada 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 yada. So what are you going to do with that? Remember, exact answers only unless stated otherwise. So this side's going to become x minus 4. But this is equal to, so you can rewrite this as the cubed root of a -6 squared. Now the negative 6 is going to square become a positive, and even if it was still negative, it doesn't matter because we can take the cube root of a negative. So that becomes the cube root of 36. And then you can try break it down to your 3 and 12, and that's going to give you a 2 and a 6, and that's going to give you a 2 and a 3. And you see that you can't even break down 36 because you don't have an even cube root of anything. So what you end up doing is you just erase that part and you just add 4 to both sides. So x is equal to 4 plus the cube root of 36, because really there's nothing else you can do with it. Alright, so that one's a little bit tricky. But that's it for now. If you have any questions, you know where to find me tomorrow. But this is Longo and I'm out. See you, bye.